Hello friends, welcome to Shiva Sai for You Basic Electrical YouTube channel. So in this video I'm going to provide solutions for assignment week 4 NPTEL network analysis course. So in assignment 4, this is the first question. So they given a network consisting of capacitor, inductor and resistance all are connected in parallel across a voltage source of 200 at an angle 45 degree. So the source has a frequency 400 radians per second. Okay, so for this particular question, they given the current flowing in each parallel branch, that is current in capacitor IC at an angle theta C, current through inductor IL at an angle theta L, current through resistor IR at an angle theta R. Some supply current flow here. That supply current will divide in all these branches. Adding all this current, you will get a supply current. So let's see what we need to find in the question. You need to find what is the magnitude of IC, theta C, IL, theta L, IR and theta R, and also estimate the active power supplied by the source. How much power this source is going to supply to this entire network. Active power supplied by the source, that we need to calculate. And then estimate the reactive power supplied by the source. What is the reactive power supplied by the source? That we need to calculate. We know that unit of reactive power is volt ampere reactive, unit of active power is watt. For simplicity, consider, see IC at an angle theta C. This capacitor and inductor are connected in parallel. I am finding effective of this one. Okay, I want to reduce this network. This two, one element is capacitor and inductor. I want to make one element. Okay, so I don't know which one is dominating. According to that, it may become inductive circuit or capacitance circuit. Okay, let's see. So J omega L, okay, inductive reactance, J omega L is parallel with minus J divided by omega C, otherwise 1 by J omega C. So J, what is omega? What is the omega given? 400 radians per second into, what is the value of inductor? 25 milli. That is parallel with minus J divided by omega is 400 radians per second into, what is the capacitance value? 0.25 millifarad. So or else in a simplified way, JXL, okay, for inductor we need to write plus JXL, and for capacitor we need to write minus JXC. XL is omega L, XC is 1 by omega C. Okay, like that. This and this both are same only. So now when two are connected in parallel, we can write like this: JXL into numerator we can multiply the reactance, denominator we can add it. JXL into minus JXC all divided by JXL plus of minus JXC. So that becomes, see, J into J, J square. J square value is minus 1. Minus 1 into minus plus. So numerator is XL XC. Denominator is JXL minus JXC. Now substituting the value of XL here. So what is the value of XL? 400 radians into 25 milli into XC value is 1 by 400 into 25, sorry, 0.25 millifarad. 400 get cancelled. This milli and milli get cancelled. 25 divided by 0.25, you will get a 100. Then what about denominator? J, XL value is what? Omega L. Okay. Minus J, what is XC? 1 by omega C. Okay. So now this entire part becomes J10 minus this 1 by something of this. That also produces J10 plus J10 minus J10 get cancelled. 100 by 0 is what? Infinity. So the parallel combination of this gives an infinite reactance. Means we can make open circuit. Okay. So this terminals we can make it as open circuit. So now the circuit is reduced only this much. Okay. Now the entire network will be this much, and here terminals are left open. So that is because we have infinite reactance. Now let me check out what is the current passing in the in this loop. Okay, voltage. See, if I find voltage at this point, since all are connected in parallel, whatever voltage here in 30 ohm resistance, same voltage in inductor and same voltage in capacitor. Okay, once we know the voltage at this point, later voltage by this reactance will get a current. So from that we can find RMS value of current and angle. Okay, so according to this, since in reactance we got infinite between these two, so that made it as open circuit. Now the circuit is only this much. So now IR, apply KVL to this loop. So voltage by resistance, these two are connected in series. 200 at an angle 45 is an applied voltage, 70 plus 30. So from this we got a current 2 at an angle 45 degree. This is what the supply current. So what is current passing from the source? 2 at an angle 45 degree. That same current is passing here. Okay. So now with the help of this supply, by knowing the supply current, we can find the current in inductor and capacitor. Okay, by using that node analysis. Okay, what is the voltage at this point? Okay, voltage by resistance. Okay, so got it. Otherwise, you can use current division rule. Okay, so that is also correct. Let's check out what is current through the capacitance. Current through the capacitance. Okay, see now current through the capacitance is, I want to find current in this resistor. For this in this capacitor, we know the supply current is IR. Okay, I want to find current in this branch. We need to take opposite resistance. IR into 30 divided by 1 by j omega c. 1 by j is minus j. IR is 2 at an angle 45 into 30 divided by 1 by j is minus j. Omega is 100 into 0.25 milli. So by doing all this in a calculator, so finally we got an answer 6 at an angle 135 degree. So they mentioned enter the value of IC in terms of RMS. See, in polar form, magnitude is called RMS value, and this theta is in degrees. Okay, IC is 6 ampere, theta C is 135. You can enter it in the MCQ or in the options. Okay, next, similarly, what is current flowing through the inductor? Okay, see, current flowing through the inductor, I want to find current in this. Okay, between these two, I want to find current in inductor. So for that, supply current into opposite resistance divided by reactance. Okay, so that is IR into 30 divided by J into 400 into 25 by 1000. Why I written 1000 here? 25 milli is there. I taken that to downwards. See, or else otherwise, I will tell you once again here. What is this numerator part? Sorry, it's not. Sorry, friends, it's not a current division rule. So it is parallel circuit concept. Voltage in all these elements are same. So what is voltage at this 30 ohm resistance? Current flowing in 30 ohm resistance is IR into that resistance. Okay, here the value of IC is nothing but V by XC. Okay, V by XC. Got it. So what is voltage in that resistor? Okay, whatever voltage is here, same voltage will be here and then here also. So therefore, so current is 2 at an angle 45 degree into 30 divided by this entire thing value is XC. Okay, got it. So by solving that, we got like this. Similarly, what is voltage across inductor? Current through the inductor, voltage divided by reactance in that inductor. Okay, so that is IL is equal to IR into 30 divided by J omega L. 25 into 10 power minus 3. That minus 3 taken down, it become 1000. By doing this, we got an answer 6 at an angle minus 45 degree. So we need to represent the value of IL in RMS, that is 6 ampere, and theta L is in degrees, minus 45 degree. So they given a range in the question in the options minus 180 to plus 180 degree. Within that you can enter. So enter this value. Theta L value is minus 45 degree. So then what about theta R? Theta R is, you need to refer current in resistance. Okay, this is theta R value, this is IR value. Okay, RMS value of IR is 2 ampere, theta R is 45 degree. So after that, power supplied by the source. What is active power formula? VI cos pi. What is voltage? What is RMS voltage? 200. What is the RMS value of current? 2 ampere. Okay, into cos pi. So what is this pi? Pi indicates angle between supply voltage and current. What is angle? What is angle here? 45 degree. What is the supply current angle? 45 degree. So the phase difference between these two, 45 and 45. So both are same only. Okay, there is no difference in this. Okay, so the phase angle is 0. Why means, see, with respect to some reference axis, voltage is lead the reference axis by 45 degree. So but it is having some magnitude 200. Okay, this is 200. But what about current? Current magnitude is 2 ampere only, but that also lead the reference axis by 45 degree. So both are in the same axis only. Then what is the angle between current and voltage? So 0 only. So cos pi is 0. Cos 0 is 1. 200 into 2, 400 watts. So now estimate the reactive power supplied by the source in VAR. See, source voltage and source current are in the same phase. That is what written here. Same phase. Current and voltage are in same phase. In phase. Thus the reactive power supplied by the source means the value of pi, cos pi, this value pi becomes 0. Reactive power formula VI sin pi. Therefore, Q is equal to 200 into 2 into sine 0. Sine 0 is 0. 0 into something 0. So therefore, this voltage source, it does not supply any reactive power. It supplies active power of 400 watts. Okay, got it?